So today, since we've done a couple of videos on binary and ternary notation, I can't resist doing one more to point out something which might surprise you, which is that just as in decimal notation, I can have something like 57.23, and I can use this decimal point here to represent a number which is not a whole number in decimal notation. So too, in binary, I can write down a number like 1011 and put a point and add something to the end of it. And this, which is by analogy called a binary point, also distinguishes the whole number part from the sort of fractional part. Okay, now how does it work? Well, in a decimal, like this is the ones column, 10 to the 0, and this is the tens column, 10 to the 1. And if I had some other number over here, like maybe this is 257, this is the hundreds column, and so on. And what the decimal point does is it tells you what's the point when we switch over to fractional parts. So this is the tenths column, which is 10 to the minus 1. And this is the hundredths column, which is 10 to the minus 2. Right? So this is this represents 2 times 100 plus 5 times 10 plus 7 times 1 plus 2 times 1 over 10, which is 10 to the negative 1, plus 3 times 1 over 100, which is 10 to the minus 2. Right? This is 2 tenths and this is 3 hundredths, and we're just adding those on. So that's how we can, following the exact same pattern, 0, 1, 2, powers of 10 going up in this direction, and powers of 10 going down in this direction, we get our normal notion of how to write a decimal using the decimal point, and we can also do the same thing in binary. So this becomes, the ones column, actually I didn't leave myself enough space here, so let me write out 1, 0, 1, 1 with a bit more space. So here we have the ones column, the twos column, the fours column, the eights column, and over here, give myself some more space, we have the halves column, the quarters column, the eighths column, and so on. So this number here becomes 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1 plus, so that was these 4 parts up here, 1 times a half from the halves column plus 0 times a quarter from the quarters column plus 1 times an eighth from the eighths column. So this is equal to 8 plus 2 plus 1, so that's 11. And then we have a half plus an eighth, which is 6 to 5 in decimal. So this is the binary representation of the decimal number 11.625. Right, that's because a half gives me 0.5 and an 8 gives me 0.125. You figured that out. And actually, I want to end the video with one more somewhat surprising fact. So maybe I'll use this side for that. So we know that in a decimal system, we sometimes have repeating decimals. So I might have something like 0.3333 and so on repeating. And we know, although I haven't proved it in a video, I'll do that at some point, but it's well known that this is the decimal representation of 1/3. Whereas by contrast, if I write something like 0.5, that's the decimal representation of 1/2. So there's kind of a difference between these two fractions in their decimal representations. Half has a nice sort of short decimal representation, whereas a third has this sort of awkward repeating decimal representation. They both have decimal representations, but this one's finite and this one is repeating. But that is not something that's inherent to the nature of the fraction 1/3 versus the fraction 1/2. because, so this is in decimal. But let's look at in ternary. In ternary notation, so this is base 3, right? We looked at this in the last video. In base 3 notation, 1/3 would just be written 0.1, because this is the 1/3 column. And meanwhile, 1/2 would be written 0.11111, repeating. And this is essentially what you need to check this is true, is to check that 1/3 plus 1/9 plus 1/27 plus 1/81 and so on eventually equals half. And this is also something that at some point in the video I'll talk about infinite series. But all I wanted to point out today is that if I switch from decimal base 10 notation to ternary notation, I flip the nature of 1/3 and 1/2 in terms of how they're represented. In decimal notation, 1/3 is the repeating decimal, and 1/2 is the one that's nice and compact. Whereas in ternary notation, 1/3 has in this nice compact representation, whereas 1/2 can only be represented with a repeating expression here, with this ternary point telling me that this is the 1/3 column, the 1/9 column, the 1/27 column, and so on.